Bromine is a chemical element with the symbol Br. Its atomic number is 35, meaning it has 35 protons in its nucleus. It is the third largest halogen and is a reactive nonmetal. Similar halogens include fluorine, chlorine, iodine, and astatine. Bromine's atomic mass is 79.904 grams per mole, meaning it has about 80 protons and neutrons combined. It has a density of 3.1 grams per centimeter at a temperature of 20 degrees Celsius. Bromine has a melting point of negative 7.2 degrees Celsius. Bromine is a fuming red-brown liquid at room temperature, but pressure is a red vapor. As an aqueous solution, bromine has a solubility in water of 0.33 milligrams per milliliter. It is an oxidizing agent and disproportionates rapidly in basic water. It evaporates readily at a standard temperature to form a similarly colored gas. Bromine has a strong and disagreeable odor resembling that of chlorine. Elemental bromine is very reactive. It does not occur freely in nature, but rather in colorless, soluble, crystalline mineral salts. Bromine makes up this much of the Earth's crust and this much of the Earth's oceans. However, its high solubility has caused some excess accumulation in the oceans. Many bromine compounds are therefore no longer used. Bromine was often used in agricultural chemicals, dyestuffs, and insecticides for environmental reasons. Now it is also used in drilling fluids and photographic film. Humans are composed of this much bromine, and scientists argue if it is an essential element for life. As a pharmaceutical, the bromine ion, Br-, has inhibitory effects on the central nervous system. Bromine salts were once a major medical sedative before being replaced by shorter-acting drugs. Bromine retains compounds used as anti-epileptics, and pure bromine costs $5 per 100 grams. An empirical formula shows the smallest possible integer ratio of atoms in a compound. Bromine can form several different unstable oxides in the first column, and several ions can be bromine oxides in the second column. A common compound is bromine monoxide, with the empirical formula BRO. This is bromine's electron configuration, and the shortened version is AR 4s2 3d10 4p5. This is bromine's distribution of electrons, or atoms, or molecules in orbitals. Each number denotes the energy of the electron, and each letter refers to the shape of the orbital. A valence electron is an electron that is associated with an atom, which can participate in forming a chemical bond. Valence electrons that are found in s and p orbitals have the highest energy. Based on electron configuration, bromine has 7 valence electrons. These come from the 4s2 and 4p5 orbitals. Covalent bonding involves sharing electron pairs between atoms. There is a covalent bond between bromine and chlorine atoms, for example. Ionic bonding involves attraction between oppositely charged ions. Most bromides form ionic bonds as opposed to bromines. Bromide is a chemical compound containing a bromine atom with an ionic charge of -1. Cesium bromide, for example, is an ionic compound made from bromine that is very soluble in water. Redox reactions, or oxidation-reduction reactions, use the transfer of electrons between two species. This involves a reduction process and complementary oxidation processes for electron transfer. Bromine ions are strong enough reducing agents to reduce acids. Sulfuric acid, for example, is reduced by bromide, which is then oxidized to bromine. According to its value, bromine is electronegative with a reading of 2.8. For example, when reacting with iodine, bromine forms a nonpolar covalent bond. This is calculated by 2.8 minus 2.5 with a difference of 0.3. They are nonpolar covalent because their polarity is rather insignificant. The electron affinity of bromine is minus 324 kilojoules per mole. This is the amount of energy released or spent when an electron is added to bromine. Electronegativity of bromine is 2.96. This is a measure of tendency of an atom of bromine used to affect a bonding pair of electrons. Atoms measure in a range from 30 to 300 pm, which is also 0.3 and 3 angstroms. Bromine measures 1.12 angstroms. Bromine is diamagnetic as opposed to paramagnetic. This description is based on magnitude, direction, the magnetic dipole moment, and intrinsic spin property. Now it's your turn. How many inner core electrons does bromine have?